Welcome to this training video on the guide rail condition. Specifically, we'll be looking at rustic guide rail. We're going to start though with a comparison with galvanized guide rail. This particular sample of guide rail you see, we can tell by this splice arrangement, dates from the early 60s. So this is galvanizing that has just about spent its life. It's in fairly poor condition. Before we get into the actual testing process, I do want to point out that there are safety considerations you need to take care of since this is a field assignment work. You need to wear a vest, a hard hat. Your vehicle needs to have an amber light. Depending upon the specific highway you're on, it may be appropriate to have additional safety protection. In a lot of your rural guide rail settings, one of the issues you have to watch out for is what I'm standing in, which is a mix of Virginia creeper and poison ivy. So that is a safety consideration. Also, there's potential for broken glass to be along the side of the road, so you need to wear foot gear that has a good stout sole on it. We used a variety of hard objects to test that 40-year-old box beam and found we got essentially the same ring out of every one of them, indicating that even though the galvanizing was shot, the rail itself was still in good condition. The noises were essentially indistinguishable, but since this is one factor that is under our control, we want to eliminate the variability by using a standard object to strike the rail. For that, any 16-ounce hammer will do just fine. Listen and you hear the protracted ring. That indicates there's absolutely no rust inside of this rail. What we have at this site is some A588 self-oxidizing, self-weathering, controlled oxidizing, Core 10 rustic guide rail. This particular installation is near the water, and that tends to be one of the factors that accelerates the deterioration of the rustic guide rail. As opposed to the galvanized guide rail that we saw previously, this guide rail has a lot of internal rusting that's taken place. When I strike it with a hammer, you'll notice it has almost no reverberation to it. It's what we call practically a thud result. So there's hardly any ringing. The sound will go to the far end and you get that one sound coming back, but there's no protracted ringing as if it was a bell. You may also have noticed that there was rust that fell off of the box beam. That would be a real key that you've got some deteriorated rail. So this, we would have to say, is in pretty bad condition. This guide rail here is severely deteriorated. This would have the worst rating of the whole series. We have holes in the top, holes in the side. It tends to be concentrated near the joint because that was some of the first place that dust and salt were introduced from the road. There's a plate in here, and at the end of the plate we have a hole. Plate in here, we have a hole, and we have the bottom is gone from a portion of this. Furthermore, the posts themselves are only holding the thing vertically. This is not actually fastened to the rail. So this is the worst case condition you can find. A couple of points about where on the guide rail to test and when you can test it. If your guide rail has a whole bunch of dew on it or snow, that's going to have the same deadening effect to the sound as if it has rust inside of it. So you want to do your testing on the box beam when it's dry and you can get a good ring out of it. Another point is where you test on the rail. You'll get the best definitive sound if you hit near the middle of the length of the piece. For instance, here you may be able to hear a relatively good ring. And as we work our way down towards the end, you see near the end of it, the end effects allow a lot of the noise to dissipate out into the air, so you don't get as good a sound as you do near the middle of the run. So most of your testing for sound should be near the middle of the piece. In this section, you see one of the things that you may have to be a little bit aware of, and that is that sometimes the guide rail will get struck, and as a result of the accident, you'll have to have pieces replaced. Here we see a situation, you can probably tell from the color difference, that this is older guide rail, whereas this here is newer guide rail. We can also verify the difference by listening to the sound. This is a fairly new guide rail, so we should expect little rust buildup. As you can tell, the ringing goes on and on. That indicates there's no rust buildup inside of this. It's in good shape. If we listen to the older guide rail, you get a little bit of ringing, so it's not as bad as some of the other guide rail, but you can tell it has a little bit of age to it. This is the same run of guide rail, but a different piece. When we strike it, notice there's no ongoing reverberation with it. Just kind of a hit, and then the sound dies very quickly. This is rail that you'd have to say is in bad condition. Not as bad as something that has holes through it, but clearly in need of replacement. The fact that there's a few good pieces doesn't mean that this is a rail that needs to be treated as good rail. It's still rail that should be replaced. At this site we have one of the other kinds of rustic guide rail that's used in New York State. Behind me is rustic corrugated or W-beam guide rail. Unfortunately, we can't use the same hammer method to test this rail because we won't get the ringing sound out of it. However, we do have direct access to be able to measure the thickness of the rail. The critical location is where the two pieces lap together. That's where moisture can accumulate and where you get some of the severe corrosion. To measure the thickness of the rail itself, we'll use a micrometer. This device allows you to screw this in and get a precise reading on the thickness of the rail. The typical W-beam is about 1/10 of an inch thick. With a micrometer, we can measure down to hundredths of an inch. You look at the shaft and you can read the tenths of an inch, and then by looking at the numbers that are around the collar, you can read down to the tenths and hundredths. We'll start out by taking some sandpaper and just give a few gentle scrapes on each side. Knock off the high spots. Then we'll take the micrometer, slip it over, and then we dial it down, twist it down until it gets tight. Now we can make our reading. This is less than 1/10 of an inch, so we know that it's already lost some thickness. When we come over here to read the actual measurement, it's 0.057 inches thick. So at 0.057, it's lost approximately half of its thickness. At this location, we see where some of the typical deterioration takes place. This is where the two pieces of W-beam overlap each other, and moisture has been able to hide inside of it, protected from the sun and the wind. And as a result, we see this hole down here, which has occurred right under the edge of the back piece of W-beam. So this is a typical location for deterioration. As the deterioration of the joint advances further and further, you reach at a point where the rail is actually cut right in half and falls off of the post. Here you see an example where the rail has been completely weathered through. This whole thing is in dire need of repair. Thank you. Just kind of a hit, and then the sound pulled up.